Hello everyone, today I want to talk to you about high pressure sodium lamps and metal halide lamps. I'm going to show you first what they look like before we even talk about them. This is a sodium vapor lamp is what they call it. A sodium vapor lamp is a gas discharge lamp that uses sodium in an excited state to produce light at a characteristic wavelength near 589 nanometers. Two varieties of such lamps exist: low pressure and high pressure. Low pressure sodium lamps are highly efficient electrical light sources, but their yellow light restricts applications to outdoor lighting such as street lamps, where they are widely used. High pressure sodium lamps emit a broader spectrum of light than the low pressure lamps, but they still have poorer color rendering than the other types of lamps. Low pressure sodium lamps give only monochromatic yellow light, inhibiting color vision at night. Single-ended self-starting lamps are insulated with a mica disc and contained in a borosilicate glass gas discharge tube or arc tube with a metal cap. They include the sodium vapor lamp that is the gas discharge lamp used in street lighting. Now here is the development of the low pressure sodium lamp. The low pressure sodium arc discharge lamp was first made practical around 1920, owing to the development of a type of glass that could resist the corrosive effects of sodium vapor. These operated at pressures of less than 1 Pa and produced a near monochromatic light spectrum around the sodium emission lines at 589.0 and 589.56 nanometers wavelength. The yellow light produced by these limited the range of applications to those where color vision was not required. Research into high-pressure sodium lamps occurred in both the United Kingdom and the United States of America. Increasing the pressure of the sodium vapor broadened the sodium emission spectrum so that the light produced had more energy emitted at wavelengths above and below the 589 nanometer region. The quartz material used in mercury discharge lamps was corroded by pressure sodium vapor lamp. A laboratory demonstration of a high pressure lamp was carried out in 1959. The development by General Electric, or GE, of a sintered aluminium oxide material with magnesium oxide added to improve light transmission was an important step in construction of a commercial lamp. The material was available in the form of tubing by 1962, but additional techniques were required to seal the tubes and add the necessary electrodes. The material could not be fused like quartz. The end caps of the arc tube would get as hot as 800 degrees Celsius or 1,470 degrees Fahrenheit in operation, then cooled to room temperatures when the lamp was turned off. So the electrode terminations and arc tube seal had to tolerate repeated temperature cycles. This problem was solved by Michael Arendesh at the GE Nella Park plant. The first commercial high-pressure sodium lamps were available in 1965 from companies in the United States of America, the United Kingdom, and the Netherlands. At introduction, a 400-watt lamp would produce around 100 lumens per watt. So that's around 50,000 lumens, I think. Single crystal artificial sapphire tubes were also manufactured and used for the high-pressure sodium lamps in the early 1970s, with a slight improvement in efficiency. But production costs were higher than for polycrystalline alumina tubes. So there is a little bit that you know about high-pressure sodium lamps. And I was not reading off a computer. Okay, yes I was, but there's a reason for it. Because it shows a bit more information than I already know. And yeah. Now let's move on to mercury vapor lamps. Osram 250 watt mercury vapor lamp. Mercury vapor lamp is a gas discharge lamp that uses an electric arc through vaporized mercury to produce light. The arc discharge is generally confined to a small fused quartz arc tube, mounted with a larger soda lime or bosculate glass bulb. The outer bulb may be clear of coated with a phosphor coating. In either case, the outer bulb provides thermal insulation, protection from the ultraviolet radiation the light produces, and a convenient mounting for the fused quartz arc tube. Mercury vapor lamps are more energy efficient than incandescent lamps, with luminous efficiencies of 35 to 55 lumens or watts. There are other advantages, are a long bulb lifetime in the range of 24,000 hours and a high intensity light output. For these reasons, they are used for large area overhead lighting, such as in factories, warehouses, and sports arenas, as well as for street lights, commonly used. Mercury lamps produce a greenish light due to mercury's combination of spectral lines. This is not flattering to human skin color, so such lamps are typically not used in retail stores. Color-corrected mercury bulbs overcome this problem with a phosphor on the inside of the outer bulb that emits at the red wavelengths, offering whiter light and better color renderation. Very interesting. These things are actually quite impressive, yeah. Yeah, it's crazy. Yeah, when this one glows, it starts off a little bit of a pinkish color, and then as it warms up to its original temperature it's supposed to be at, it basically becomes like a white light, very, very white, like a warm white, between a cool white and a warm white. So it's basically pure white. That's what it is. It's the color. Quite interesting, actually. If you want to see what an actual mercury vapor lamp looks like here, that was a mercury vapor lamp. This right here, my friend, is a metal halide lamp. 350 watts, pulse start. Quite interesting. You see a little bit of mercury in there as well, just floating around. can see it in there. But yeah, there is everything you want to know about the basics of high pressure sodium lamps, mercury vapor lamps, and metal halide lamps. Now we're going to move on to the testing segment. I have a massive industrial lamp in my room that I'm going to bring out here in just a second. Wait till you guys. Right, well, I got the lamp out just fine. We're going to see what this thing can actually do. This thing is heavy, man. Right, well, I'll let you know when I plug it in, because this is probably going to take a while. Where's your best if this is going to work? 3, 2, 1. We're going to wait for it to get out to its temperature now. This thing is loud, man. I will fast forward this part as well because I know how long stuff like this takes a while to warm up to its temperature. This is what it looks like when a metal halide actually warms up. Like this is the original bowl. And yeah. Golly, this thing's warming up fast. If you guys don't like flickering effects, yeah. I'm gonna back that away a little bit. I wish I had a spectrometer with me so I could actually measure what the color temperature is of these lights. These are nuts. Bro. I swear these have got to be more than like 50,000 lumens because these things are nuts. Right, we're basically at full brightness now, and yeah, as you can see, that is how bright these things get. Look at all this. All of that is lit up. All of that. Except for that portion. These things are nuts. Impressive lights too. See it cool down. So we don't get anywhere near these lights when they're running, ever. These things get up to at least like over 300 degrees Celsius. Yeah, ridiculous. What have I got myself into now? Sylvania Solbright, SYL Silbrit, 400 watt metal halide. Oh man, that thing was bright. This is why they're used in factories and all that. These things are nuts, man. And you can't turn them back on unless, yeah, they've cooled down completely. I wish I had a color meter with me, so that way I would be able to measure the actual brightness of this thing and the color temperature as well. Now we are not going to turn on the high pressure sodium bulbs today because obviously we don't have enough time, and I don't want to keep this video running for way too long where people are going to stop watching the video. It's yeah. Anyway guys, if you did enjoy, please like, comment and subscribe, and I will see you all next time. Peace.